Hi all, this is Alan with Bothell STEM Coach, and today we are continuing on with AP Physics 1 free response questions, and we're looking at more circuits problems. As usual, I suggest you pause the video, try to do the problem on your own, and then come back after you've attempted the problem. So I have three resistors arranged in a circuit shown above. The battery has an unknown but constant voltage and negligible internal resistance. EMF is just a fancy word for voltage, if you guys haven't picked up on that. Negligible internal resistance. So that means negligible is 0, no internal resistance. Determine the equivalent resistance of the three resistors. First, you have to identify these two are parallel because they share the same endpoints. That's the key. Like these two are not in series, these two are not in series because they don't have the same current flowing. Current flowing through here doesn't or another way to do this, current flowing through here is not the same as the current flowing through here. And so that's why these two aren't in series or these two aren't in series. But these two are parallel because the endpoints are the same. So this one, I do 4 times 12 over 4 plus 12. That would be 48 over 16. That's equal to 3 ohms. So these two collapse together becomes 3 ohms. And then I have a 9 ohm here. And then I have my battery voltage. And these two are now in series. 3 plus 9 is 12, so 12 ohm. So now they say the current in the resistor R3 is 0.4 amps. Determine the voltage of the battery. Well, from our original thing, if I'm having 0.4 amps means 0.4 amps through here means the battery is also drawing 0.4 amps, right? 0.4 amps is coming out of this battery. So and we know it's connected to the equivalent of 12 ohms. So I know that V over R is equal to I. Or actually, I want to find V. V is equal to IR, right? And it's 0.4 amps times 12 ohms. So that's 4.8 volts. So now I know it's a 4.8 volt battery. Determine the potential difference across resistor R1. Okay. When you do this, it's better to treat it like this, where it's already collapsed into the 3 ohms. Then it's very straightforward to calculate the potential difference. Because you know 0.4 amps is going here, but you don't know the exact split of the current between here and here. You could do it, but to keep it simple, I collapse into 1, and I know 0.4 is the equivalent as though 0.4 amps is going through the 3 ohms. So the voltage across there is equal to IR. The I is 0.4 amps, and the resistance is 3 ohms. So that's 1.2 volts. So this is a 1.2 volt drop between here and here. Determine the power dissipated in resistor R1. Now that I know the voltage across the resistor, I can calculate its power. Power is equal to V squared over R in this case, because the reason I use this equation is I know the voltage and I know the resistance. The voltage is 1.2 volts squared over 4 ohms. So that's 1.44 divided by 4. 0.36 watts. And then determine the amount of charge that passes through the resistor R3 in 1 minute. Okay, this is to know that the amount of the current is defined as the change in charge over time, however long that passes through. So if I want the amount of charge that passes through, I just need to do the current times the time. The current is 0.4 amps. The units of time we want in seconds, so 1 minute is really 60 seconds. And so that's 24, and the units of charge are coulombs. Okay, so I hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content, and see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.